So you guys saw normal shift, right? So see, one important point is in normal shift, the light source is always in the optically denser medium, correct? Then only you feel that shift. Now here, one thing what I want you guys to notice is, suppose let's say, see, a ray of light is going normally, so no deviation, right? Then the next one is going like this. The next one is going like this. Next one is going like this. Now, what are you noticing about the angle of refraction? It's increasing, right? So it's increasing every time the light ray is going away and away from the source. Now, when I say away, meaning it's going, the angle of incidence is also increasing, angle of refraction is also increasing, right? Now, what we come across is this particular state. See here, the light ray is grazing through the surface, right? Meaning here, what is the angle of refraction? 90 degree, right? Now, what if we increase the angle of incidence even more? Now, this is what happens, or this phenomenon is what we call as total internal reflection. Okay, in short, TIR. See, in TIR, what happens? All the light which is coming from the source, it gets reflected back to the denser medium itself. Okay, this phenomenon is TIR. Now here, very important point is the light source has to be in the optically denser medium. Only then TIR can happen. Okay, so this is one thing. Now the second point here is the angle of incidence for which the light ray was grazing through the surface. Okay, like see this one. So what we are highlighting, this one. So here the angle of incidence is what we call as critical angle. Okay, so for angle of incidence to be the critical angle, the angle of refraction will be 90 degree. Okay, if the angle of incidence is more than the critical angle, then TIR will happen. Okay, now depending on what medium we have, we can figure out the critical angle. Okay, so there is a relation between critical angle and the refractive index of the material, so which you guys will learn now. See here, what we have the angle of incidence to be the critical angle, correct? So let's say I is equal to C. C is the critical angle. Then what is the value of R here? 90 degree. Now again, use the Snell's law. Now here we have B mu A, correct? So B mu A is equal to sin C by sin 90. Sin 90 is 1. So we have B mu A is equal to sin C. Now using principle of reversibility, we can write A mu B is equal to 1 by sin C, right? So if you know the critical angle, you will get to know the refractive index, or if you know the refractive index, you will get to know the critical angle. So this particular formula is very important, that is A mu B is equal to 1 by sin C. Okay, this will give you the critical angle and the refractive index.